Welcome to lesson 5. We're going to be doing a bunch more trigonometry, so let's get started. So let's take a look at some review stuff. We're trying to find out what the cosine, which is the x value at 5 pi over 6, which would be a reference angle of pi over 6, because from the horizontal, that's the reference angle. And we know that the point out here at 5 pi over 6 is the square root of 3 over 2, comma, well, negative, comma, positive 1/2. And we know that the cosine value is the x value, so negative root 3 over 2. And 5 pi over 3 we know is over here. And the value there is at 1/2 negative root 3 over 2. And the sine is the y value, so I'm getting the same value there, so negative root 3 over 2. For this third one, we're going to find out what's going on at 5 pi over 4, which is a 45-degree angle going out that way. And we know that that value is the negative square root of 2 over 2, comma, negative square root of 2 over 2. And so this is the sine, this is the cosine. Anything divided by itself gives you 1. Negative divided by negative is positive. Let's take a look at this one. It's a little bit trickier. And if I have the secant of t is equal to b squared plus 1 all over 2b, then the cosine at t, which is its reciprocal, would be 2b over b squared plus 1. And you notice that they ask me to draw it in the third quadrant. So I'm going to draw my triangle over there. I know my adjacent is 2b. I know my hypotenuse is b squared minus 1. And to get the third side, I'm going to use friend Pythagoras to come up with that for me. So I'm going to say 2b squared plus x squared equals b squared plus 1 quantity squared. And I get 4b squared plus x squared equals b to the 4th plus 2b squared plus 1. And solving for x, I get x squared equals b squared minus 2b squared plus 1. That's a 4th. And I'm going to need more room. And if I rewrite that as a binomial squared, so I'm going to say this is the same, and I'm going to leave it as x squared for now. I'm going to rewrite it as b squared minus 1 quantity squared, then square root both sides, and so I get x equals b squared minus 1. So, back to my question up here. It says find the tangent and the sine. So I know this side over here is b squared minus 1. And pause. That's a plus 1. So let's find my tangent first. The tangent would be the opposite over the adjacent. There's my theta. So the opposite would be b squared minus 1 over the adjacent. My sine would be the opposite over the hypotenuse. And if we look at, we know that for these answers, b cannot be 0 and b squared cannot equal negative 1. Otherwise, they're undefined. So, before we're viewing the inputs of a trigonometric functions as angles, when really the inputs can be any real number. So let's talk about some additional properties of trig functions. A function is even if you can put a negative x into your function and it returns to the original. Let's think about this. The simplest even function that we know of is y equals x squared. And if we put a negative value in there, the squaring would make it the same. And if it's an odd value, if you put in a negative value in for it, that changes, it's the opposite of it. Well, let's take a look at some of these graphs. If I put in this, we know that they are equal to each other because I can put in the cosine of pi over 4 is root 2 over 2, and the cosine of negative pi over 4 is also root 2 over 2. So we know that this is an even function. And if I put this in there, we know that we get the opposite when I do this. So if I put the sine, just as one example, and I know one example isn't a proof, but it definitely gives me a little bit of knowledge about the situation. If I go with the sine at pi over 6, sine is the y value, I get a half. The sine at negative pi over 6 is negative 1/2. So I get the opposite value. So I'm going to call this one an odd function. And then the tangent is going to be, if I look at this one, we see that this is also an odd function. I'm not going to take the time to plug it in. You can look at that yourself. And periodicity, if trigonometric functions are periodic, meaning that they repeat output values outside of a certain set of domain elements. What is the period of sine and cosine? Well, we know that they are both 2 pi, because our periodic table gives us 2 pi for that. And we also know that the period for tangent is pi. So, as both functions repeat outputs every 2 pi, it is possible to say that for any value of k, that's true, because what happens pi over 6 after 0 and what happens at pi over 6 after 2 pi are the same thing, because they are repeating. So with that in mind, I'm going to say that this is going to be, if I subtract 2 pi from this, 9 pi over 4 minus 2 pi, I should get the same value as I get for this. And if I write 2 pi as 8 pi over 4, I know I get the cosine at pi over 4. And the cosine at pi over 2, or pi over 4, is root 2 over 2. And if you wanted to test that, you could put the cosine of 9 pi over 4 into the same place. Same dealio here with the sine at negative 13 pi over 6. Let's talk about coterminal angles for a second. If I have a coterminal angle, it's just a lap difference. So if I'm doing a negative angle, I'm at negative 2 pi, right there. And if I go another pi over 6, that's negative 13 pi over 6. Well, that would be the same as the sine of negative pi over 6. Which would also be the same as the sine as 11 pi over 6, if I keep adding 2 pi to these values. And we know that the sine is the y value here, and so for all of these values, I get negative 1/2. What is the period for tangent? We know that that's equal to pi, so if I add pi multiple times, I'm going to keep getting equivalent answers. So if I just say I'm going to add 6 pi over 3, I get negative 10 pi over 3. If I add another 6, I get negative 4 pi over 3. If I, I'm adding 2 pi there. Let me add pi. So negative 13 pi over 3. Negative 10 pi over 3, negative 7 pi over 3, negative 4 pi over 3, negative pi over 3, and if I add another one, positive 2 pi over 3. should all give you the same answer because every pi, the tangent is at the same place. So if I look on my graph, we know that the tangent at 2 pi over 3 is going to be the negative square root of 3. All right. So I sent you these to fill in, this one period of sine and one period of cosine. Hopefully you took the time to fill those in. In here, we know that the sine starts there, goes up to 1, back down to 0, down to negative 1, and back up. And it'll look like that. We also know that the cosine, if we look at our unit circle, it starts there, goes there, down to negative 1 there, and back up. And it'll look like that. You can look at your first graph that you made, and that's going to help you out immensely going forward. So the graphs of sine and cosine are on my picture there. The range is going to be from negative 1 to 1. And we know that it's periodic. From here to here is one period, and from here to here is another period. So every 2 pi, it's at the same place, and it continues forever and ever. What is the maximum value of each function when it's obtained? Well, 1 is the highest value of both of them. What is the minimum value of each? Well, we know it goes as low as negative 1. What is the amplitude? Well, the amplitude is the distance between the axis of oscillation, which is the middle of the road here, up to the top and down. So from the axis of oscillation up and the axis of oscillation down should be the same. And in both cases, we get 1. And I don't think you can see the bottom question. What are the roots, x-intercepts, and zeros of the function? Well, for the sine, we know that we get a 0 pi, 2 pi, 3 pi. And if we wanted to say all of them, we could say 0 plus pi n, where n is a positive or negative number. Now, the zeros of cosine of x, we said that we found those at pi over 2, 3 pi over 2. Woo, what did I just do? There we go. 3 pi over 2, and 5 pi over 2, and 7 pi over 2, which means basically every pi. And if I wanted to write all of them, I would say pi over 2 plus pi n, which means n can be positive or negative, so I could find all the zeros going to the left also. Determine the period and amplitude of this trig picture. So if we look at that, we know that, it's hard to tell on here, but this one is pi over 2. And we also know that this is pi over 4. And if I go from, let's go from here to here, that would be one period. You see this value being 3.142857. So we know that from pi over 2 to pi is one period. So the period of this thing is going to be pi over 2. And it could be that I'm going from this value to this value. It doesn't matter where I went. I went from the numbers that I knew is basically what I was using. And my amplitude, let's find the amplitude of this thing. Well, to find the amplitude, I'm going to take the lowest number, the highest number. I'm going to take 5 minus negative 1 and I know that I get 6 is the most difference. So if I divide that